This presentation is about Code Tracker, a tool that can extract the commit change history for variables and methods, and is the outcome of the master thesis of Mehran Jadavi. Developers very frequently track code change history for various reasons, such as to recover the rationale behind a snippet of code, to find the commits that introduce a bug, or to find teammates that are knowledgeable about certain modules, among other reasons. However, the blame and text diff tools that they're commonly using are not sufficient for their needs. Grun and his colleagues surveyed professional developers and found that they prefer the source code change history information at the method or functional level rather than the file level. And they also expressed that the current tools are unable to find the commit that introduced the method. Latosa and Myers also surveyed developers at Microsoft and asked them about hard-to-answer questions regarding code. The developers made some questions like, where was this variable last changed? When, how, by whom, and why was this piece of code changed or inserted? And how this piece of code changed over time. To address their needs, several researchers developed tools that can track specific program elements. For example, we have tools that can track the change history of functions, methods, types, and fields at either commit level or release level. However, these tools have some limitations. The first limitation is that they depend on similarity threshold. And it is very hard to come up with universal thresholds that work well for every kind of project. Therefore, these thresholds need to be calibrated for projects with different characteristics. The second limitation is that they are partially refactoring aware. At the best, they support method signature changes, method moves, and file renames or moves. There is no support for extract and inline method refactorings, and as a result, these tools tend to mismatch methods from which a significant part of their body has been extracted to a new method. And finally, there is no tool that can support tracking the change history for local variables. Our contribution is that we improve both precision and recall in method tracking over the state-of-the-art tool called Sovel. We're the first to support variable tracking with 99.7% precision and 99.8% recall. We fix and extend the oracle initially developed by Grun and his colleagues by adding the change history of 1,345 variables. And finally, we propose evolution hooks as a way to model the change history of methods that are extracted or inline from the tracked method of interest. In order to provide a fully refactoring-aware solution, we relied on Refactoring Miner, which is a tool developed in our group that supports over 90 different refactoring types with very high precision and recall. The challenge is how can we take advantage of Refactoring Miner accuracy in a way that is not so computationally expensive. And our solution is to apply partial and incremental commit analysis based on the location of the tracked program element. In a nutshell, our approach consists of 5 steps. The input required is a Git repository URL, the start commit ID, the file path where the program element is located, the program element name, and the start line number for the program element declaration. In the first step, we execute this git command, git log -follow, for the specified file path in order to find the subset of commits in which file path has been changed or file path itself has been renamed or moved. For each commit in this subset, we execute the 5 subsequent steps. Now, in order to execute step 2, we first create a partial model for the child and parent commits that include only the source files corresponding to file path. And in step 2, we try to find in the parent commit a program element that has identical signature. If this program element is not found in the parent commit, then in step 3, we relax the signature by omitting the method body hash value. Again, if a match is not found, then we proceed in step 4, where we execute refactoring miner in order to find a method that is best matching the method that we're tracking. And this will be a method with a change in the signature. So the method will be either renamed or there will be some change in the parameters. If by the end of step 4, the program element is not found in the parent commit, then that means that the program element is either moved to another file or its container file has been renamed or moved. So in order to track it in the parent commit, we need to add some additional files. So now in the original partial models, we add all modified and deleted files in the parent commit. And we also add a few modified files in the child commit that match some heuristics which need to be checked in order to support the cases where the program element is either extracted to a new class or is copied to a new class. In step 5a, we execute the refactoring miner to check whether its parent container has been renamed or moved. And finally, in step 5b, we use again the outcome of refactoring miner to check whether the program element itself has been moved to another container. If at any step the program element is located in the parent commit, then we skip all subsequent steps and proceed with the next commit. If the program element is found as introduced, then the entire process terminates. In order to evaluate our tool, we examined 4 research questions that are related to its accuracy and its execution time. In order to evaluate the accuracy, we extended the code shovel oracle, which includes the change history of 200 methods from 20 different open source projects. First, we corrected the discrepancies we found due to incorrect matches of methods with methods extracted from their body. We found 27 cases in total. We also added some newly supported changes for annotations and documentation. And finally, we added the change history of 1,345 variables that are declared within these 200 methods. With respect to method tracking, we computed precision and recall at both commit and change level. With respect to precision at commit level, our tool achieved an increased precision of 7%, while recall increased by 4%. Now at change level, we see that the precision increased by 9%, while the recall increased by 6% compared to code solo. With respect to variable tracking, Code Tracker achieved the precision and recall that is over 99.6% at both commit and change level. Regarding execution time, here you can see 2 violent plots that show the distribution of the execution time for recovering the entire change history for methods. Code Tracker is 1.6 times slower. So on median, it can extract the complete change history for a method in 3.3 seconds, while on average it takes 5.5 seconds. Although Code Tracker is a bit slower, still the execution time is within the same order of magnitude as that of code solo. In order to compute the speed up over refactoring miner, we execute the refactoring miner with its default operation mode. That means all modified and added files in the child commit and all modified and removed files in the parent commit. And we compare that with the execution time of Code Tracker in steps 2 to 5. Code Tracker was 3 times faster on median and 7 times faster on average. And despite this significant speed up, there was only a small number of false positives and false negatives that was introduced, and this was due to method move changes that were misreported as file moves due to the partial models that we used. In conclusion, I presented to you Code Tracker, which is a fully refactoring aware commit change history tool. It is using no similarity thresholds. It has a very high accuracy, over 99%. It is very fast. It takes on median 3.3 seconds to extract the entire commit change history. and is also better than competitive tools such as CodeSovel with increased precision and recall. As part of our current work, we already extend the tool to support field and block tracking, such as loops, try, and if statements. And we also made a Chrome extension to show the change history directly on GitHub, which we will use in order to conduct some experiments with developers. Thank you very much for your attention.